Mercury. The name conjures images of blistering heat, a desolate wasteland baked by the sun's relentless glare. It's a world of extremes, a place where temperatures can swing from searing hot to unimaginably cold. Yet despite its proximity to our star, Mercury remains one of the least explored planets in our solar system. This tiny world, the smallest of our planetary neighbors, holds secrets that have intrigued astronomers for centuries. Its surface, scarred by ancient impacts, whispers tales of the early solar system. Its unusual composition and magnetic field hint at a turbulent past and a complex evolution. Mercury is a puzzle, a cosmic riddle waiting to be solved. It's a planet of stark contrasts where scorching sunlight illuminates a world cloaked in perpetual twilight. Its thin atmosphere offers little protection from the harsh realities of space. But despite its unforgiving nature, Mercury beckons us to explore, to unravel the mysteries hidden beneath its cratered surface. The challenges of reaching Mercury are significant. The intense gravity of the sun makes it difficult to achieve orbit. The extreme temperatures and radiation pose constant threats to spacecraft. Yet the scientific rewards are immense. By studying Mercury, we can gain a deeper understanding of the formation and evolution of our solar system. We can learn more about the processes that shape the inner planets, including our own. Be sure to check out the video description for information about our partners and get exclusive coupon codes for a 10% discount at the Space Shop. Every purchase made through our links helps grow this channel and allows us to make more awesome content. Thanks for your support and enjoy the video. Mercury is a planet of extremes. It is a world where the environment is as harsh as it is fascinating, offering a glimpse into the raw power and beauty of our solar system. It's the smallest planet in our solar system, just a little larger than our moon. Despite its size, Mercury holds many secrets and surprises that continue to intrigue scientists and astronomers. If you could stand on its surface, the sun would appear 3 times larger than it does from Earth. This immense size is due to Mercury's close proximity to the sun, orbiting at an average distance of just 36 million miles. And it wouldn't be a pleasant experience. The surface is bombarded with intense solar radiation, making it one of the most inhospitable places in our solar system. Mercury has the largest diurnal temperature variation of any planet in our solar system. This means that the difference between daytime and nighttime temperatures is more extreme than anywhere else. During its long day, which lasts for 176 Earth days, temperatures can soar to a staggering 800 degrees Fahrenheit or 430 degrees Celsius. This extreme heat is a result of Mercury's slow rotation and lack of a significant atmosphere to distribute heat. This intense heat is enough to melt lead. Imagine standing on a surface so hot that common metals would turn to liquid. But as Mercury rotates slowly, a different extreme takes hold. The night side of the planet experiences a dramatic drop in temperature. The lack of a substantial atmosphere means that heat escapes rapidly into space. Without an atmosphere to trap heat, the surface cools quickly once the sun sets. Temperatures on the night side plummet to minus 290 degrees Fahrenheit, or minus 180 degrees Celsius. This makes Mercury a planet of both scorching heat and freezing cold. This dramatic temperature swing is just one of the many fascinating characteristics of Mercury's surface. The planet's ability to endure such extremes is a testament to its unique position in the solar system. The planet is heavily cratered, a testament to its long history of bombardment by asteroids and comets. These impacts have shaped Mercury's surface over billions of years. These impacts have left their mark, creating vast plains and towering mountains. The geological diversity of Mercury is a record of its violent past. Mercury's surface is also crisscrossed by cliffs, some stretching for hundreds of miles. These cliffs, or scarps, are among the most striking features on the planet. These features, known as scarps, are thought to have formed as the planet cooled and contracted billions of years ago. The cooling process caused the surface to shrink and crack, creating these dramatic cliffs. Despite its harsh conditions, Mercury has a surprisingly familiar feature ice. This discovery has added a new layer of intrigue to our understanding of the planet. Yes, you read that right. Even on a planet so close to the sun, ice can exist in the right conditions. Observations have revealed the presence of water ice in permanently shadowed craters at Mercury's poles. These areas never receive sunlight, allowing ice to remain frozen. These craters, never touched by sunlight, act as cold traps, preserving the ice for billions of years. This discovery has profound implications for our understanding of water in the solar system and the potential for life in extreme environments. Our understanding of Mercury remained limited until the dawn of the space age. Before the advent of space exploration, Mercury was just a tiny, elusive dot in the sky, difficult to study due to its proximity to the Sun. Early astronomers could only speculate about its surface and composition. In 1974, NASA's Mariner 10 spacecraft made history as the first mission to reach Mercury. This mission marked a significant milestone in our quest to explore the innermost planet of our solar system. Although it was only a flyby mission, Mariner 10 revolutionized our view of this enigmatic world. The spacecraft's journey was fraught with challenges, but its success opened a new chapter in planetary science. The spacecraft made 3 close approaches to Mercury, capturing the first detailed images of its heavily cratered surface. These images provided an unprecedented look at the planet's geology, revealing features that had never been seen before. Mariner 10's images revealed a world that looked surprisingly similar to our moon. The surface was dominated by craters, some of which were hundreds of kilometers in diameter, indicating a violent history of impacts. Craters of all sizes dominated the landscape, evidence of a long history of impacts. These craters told a story of a planet that had been bombarded by asteroids and comets over billions of years. But Mariner 10 also uncovered something unexpected. Mercury had a magnetic field. This was a groundbreaking discovery that challenged existing theories about the planet. Although it was weak, only about 1% as strong as Earth's, its presence was a surprise. The existence of a magnetic field suggested that Mercury had a more complex internal structure than previously thought. Scientists had not expected such a small planet to have a global magnetic field. This finding prompted a reevaluation of our understanding of planetary magnetic fields and their origins. This discovery hinted at a dynamic interior with a molten core that generated the magnetic field. The presence of a molten core was surprising for a planet as small as Mercury, suggesting that it had retained more of its internal heat than scientists had anticipated. Mariner 10's flybys also provided the first accurate measurements of Mercury's mass and density. These measurements were crucial for understanding the planet's composition and internal structure. These measurements revealed that Mercury was surprisingly dense, the second densest planet in the solar system after Earth. This high density indicated that Mercury had a large metallic core, which was unexpected for a planet of its size. This high density suggested that Mercury had a large iron core, perhaps making up as much as 60% of its mass. The discovery of such a large core raised new questions about the planet's formation and evolution. Mariner 10's groundbreaking mission left scientists with more questions than answers. The data collected by the spacecraft provided a wealth of information, but also highlighted the need for further exploration. How did Mercury get such a large iron core? This question became a central focus for planetary scientists, leading to new theories about the planet's formation and the processes that shaped its interior. What was the history of its magnetic field? Understanding the evolution of Mercury's magnetic field could provide insights into the planet's thermal history and the dynamics of its core, and what other secrets lay hidden beneath its cratered surface. The data from Mariner 10 hinted at a complex and dynamic planet, but many mysteries remained unsolved. These questions would have to wait for future missions to answer. The legacy of Mariner 10 paved the way for subsequent missions, each building on the discoveries of the past and bringing us closer to understanding the innermost planet of our solar system. More than 3 decades after Mariner 10, NASA's Messenger spacecraft embarked on a mission to unlock Mercury's secrets. Messenger, short for Mercury surface, space environment, geochemistry, and ranging, launched in 2004 and became the first spacecraft to orbit Mercury in 2011. Over the next 4 years, Messenger transformed our understanding of the innermost planet. Messenger's instruments mapped Mercury's surface in unprecedented detail, revealing a world far more diverse than previously imagined. The spacecraft discovered evidence of ancient volcanic activity, suggesting that Mercury had a more dynamic past than previously thought. Messenger also found evidence of water ice in permanently shadowed craters at Mercury's poles, confirming earlier observations. But perhaps Messenger's most significant discoveries were related to Mercury's composition and internal structure. The spacecraft's measurements revealed that Mercury's core was even larger than previously thought, making up nearly 85% of its radius. This massive core helped to explain Mercury's high density and its weak magnetic field. Messenger also found that Mercury's surface was surprisingly rich in volatile elements, such as sulfur and potassium. These elements should have evaporated away during the planet's formation, so their presence suggested that Mercury might have formed farther out in the solar system and migrated inward over time. Messenger's mission ended in 2015 when the spacecraft, low on fuel, intentionally crashed into Mercury's surface. But the data it collected continues to provide insights into the mysteries of this enigmatic world. The wealth of information gathered by Messenger has kept scientists busy for years, analyzing and reanalyzing the data to uncover new findings. Each new discovery paints a more detailed picture of Mercury's complex history and its place in our solar system. Comparing Messenger's findings with those of earlier missions like Mariner 10 has allowed scientists to see how our understanding of Mercury has evolved. Mercury's proximity to the Sun presents unique challenges and opportunities for study, making it a key target for future missions. Future missions are already being planned to build on Messenger's legacy, aiming to answer even more questions about this mysterious planet. International collaboration will be crucial in these endeavors, as pooling resources and expertise can lead to even greater discoveries. One area of particular interest is Mercury's magnetic field, which, despite being weak, offers clues about the planet's internal structure and history. The detailed analysis of Mercury's surface features has also provided insights into the planet's geological processes and its interaction with the solar wind. As scientists continue to present their findings at conferences and in scientific journals, the story of Mercury becomes ever more fascinating. Understanding Mercury's formation and evolution not only sheds light on the planet itself, but also on the early solar system as a whole. Messenger's legacy lives on, inspiring ongoing research and future missions that will continue to unravel the mysteries of the innermost planet. As we look to the future, the lessons learned from Messenger will guide us in our quest to understand not just Mercury, but the entire solar system. If you enjoyed this video, don't forget to like, subscribe, and leave a comment below. Your support helps us bring you more fascinating content about our universe.